So this is a tweet I came across a couple years ago, posted by Fermat's Library, and it's a pretty interesting idea about how you can find whether two words are anagrams. Anagrams means that the words are made of the same letters. They're just rearranged in a different order. So the example they give down here is R and ear, right? They each have one E, one A, one R, and no other letters. They're just rearranged in a different order. What you do, they claim, is map each of the 26 English characters. I mean, you could do this with another language's characters, right? There's nothing special about 26 here, but you just match each unique character, A, B, C, D, etc., to a prime number. Why a prime number? Well, what you're going to do next is multiply all those characters together. And since every integer you get, right, you're going to get an integer out for this word, every integer is either a prime number or a unique product of primes, right? Because you can't put primes together in any other way because the order doesn't matter. If that's the case, if they're equal to each other, then those anagrams then those words are anagrams if the two products are the same. So for example, let's suppose you map A, E, and R onto 2, 5, and 7, just kind of going in order through the alphabet. Then for ARE, you're going to get a product of 2 times 7 times 5 equals 70. For EAR, you're going to get 5 times 2 times 7, which also equals 70 because scalar multiplication commutes like that, which is really cool. So what I've done is implemented that over here in VPython. So we've made a couple of alphabets here. We've got the uppercase alphabet, all 26 letters, and then the lowercase alphabet, all 26 letters. And then I've got the first 26 primes. Obviously, not all the primes, just the first 26, because that's what we need. Thank you to OEIS for making it easy to just grab an arbitrary set of primes. And so then what we'll do is ask the user for input. We're going to ask them for one word in lowercase letters and another word in lowercase letters. And this is going to tell us whether they are anagrams. And I actually miswrote this as palindromes. That needs to be anagram there. This needs to be anagrams there. And so what we're going to do, we're going to define anagrams. There we go. Anagrams. I don't know why I called it palindromes earlier. I fixed it on the program name. I just forgot to fix it in the code itself. So what we're going to do is calculate the number for each of these. So we're going to go for letter in word 1. We're going to loop over all the letters in word 1, and we're going to find that letter's matching prime. So we're going to look up where it occurs. So we're using the dot index to find out where that occurs. Is it item number 0, item number 1, item number 2, etc. in the list of the alphabet. And then we'll use that number here to access the associated prime. So if n was equal to 5, if it's the letter if it's the letter F, so 0, 1, 2, 3, 4, 5, that's going to be 0, 1, 2, 3, 4, 5. That's going to be number 13, the prime number 13. And so then we multiply that prime into the overall number, and then we just repeat that process for word 2. So number 1 goes with word 1, number 2 goes with word 2. And we're going to find out whether number 1 equals number 2. And so if that comes back true, then we'll print that they are anagrams. If it's false, we will print that they are not anagrams. So let's give this a try. We're going to run the program. Let's see. Let's try the example they give. Let's try ear. And let's try R. Now, of course, it's not checking whether these are real words. It's just checking for whether the letters are the same set, just in a different order. And sure enough, you get anagrams there. Let's try another one. Let's try Brian and brain. Sure enough, my name is an anagram with brain. Let's try a case where it does not work. Let's try umbrella and raincoat. Sure enough, those are not anagrams. Those are definitely different from each other. Let's try one more. Let's try tomato and potato. Those have some letters in common, but because it's got some that are different, those are not anagrams. So it's a cool little trick, a great way to sort of walk through properties of prime numbers, how to search things in a string, etc. You might notice we're working with an uppercase and a lowercase option here as well, just so that it doesn't matter whether they are uppercase, lowercase. We specify lowercase here, but we're safeguarding against uppercase there as well. So anyway, I hope that's fun. Maybe use that to demonstrate some things about prime numbers, some things about how to work with a loop in strings.